Welcome to this session on daylighting controls. Before we understand daylighting controls, let us understand what is a control system. A control system manages or regulates the behavior of other devices or systems using control loops. It usually consists of three parts: input, process, and output. Let us take a simple example to understand it. Suppose we have a tank and we want to maintain the water level in this tank. There is a tap from which the water is coming into the tank, and there is a valve by which we can regulate the flow of water in the tap. We put a float which tells us what is the level of the water. When the float reaches the level where we want the water to be maintained, then at that level it closes the valve. So basically we are able to maintain the water level and control the flow from the tap by controlling the valve and achieve the desired water level. So this is a simple example of control. On the similar lines, we can use controls to maintain the light levels in the space. We know that the daylight entering from windows or skylight, that will keep on changing from time to time in the day or season to season. However, we will like to have a desired illuminance level on the task surface. So to maintain that level, we will change the intensity of the light, the artificial lights, and get the desired level. We can sometimes also change the angle of the blinds or put shades and control the amount of daylight that is entering into the space. So basically, we want to control and achieve a desired lux levels on the task surface. Let us see it in a little bit more details. How does closed loop control look like? In closed loop control, we give the desired level that we want to achieve as an input, sometimes also called set point. And then we measure whether the level is equal to the set point or is it different. So we measure this as an output from the system, and we compare the input with the output, basically by subtracting the output from the input, and the value so obtained is the error. Say for example, if you want to maintain 500 lux and we currently measure the illuminance level to be 400 lux, then 500 minus 400 would be the error, that is 100 lux. This error then goes into the controller, and based on the logic that is built into the controller gives an actuating signal. That is, it tells the actuator to shift its position. In this case, it can be a light, and we can increase the intensity of the light or we can decrease the intensity of the light. Here we have less light, so it might, the control logic might give signal to the light fixture to increase the output. It can also give signal to blinds and increase the daylight coming from the windows and try to achieve the 500 lux. So basically, the controller gives the actuating signal, and then the system achieves a new state, and we measure whether our set point is being met or not. So this loop continues till we achieve the set point. How do we apply closed loop into the daylight control system? In this image, you see that there is some daylight entering from the window and it is falling onto the task table and it is getting reflected. There is some light falling from the artificial light fixture on the task, and then that is also getting reflected. Our objective is to maintain the illuminance level on this table. Ideally, we would like to have a sensor on the table which can tell us what is the illuminance level. But we cannot place a sensor on the table because it will disturb while we are working. So we put the sensor on the ceiling. So this sensor indirectly measures the light that is falling onto the table. It measures both the light reflected from the artificial fixture and the light that is coming from sun and getting reflected from the table. It cannot differentiate between the two. Now to maintain this level, once we estimate this lux level by this photosensor put on the ceiling, we can give a control signal to the lamp to dim or to brighten, or we can also give this signal to the shade and we can close it or we can open it. So in this case, suppose we are getting less lux levels than desired, then we will open the blind and try to get more daylight. And if we are not able to attain the set point even after opening the blind fully, then we will give signal to the artificial light to increase the light output till we attain the desired level. Like this, we can control the daylight coming into the space, and we can also control the artificial light and ensure that we get the right lux levels onto the table. There are some drawbacks of this system. One, the sensor cannot distinguish whether the daylight level or the artificial level has changed or the surface reflectance of the table has changed. So if the table reflects more, the sensor will give signal as if the lighting levels have gone up. The other problem is that the sensor cannot differentiate between the artificial light and the daylight. It only knows the total amount of light that is falling onto the table. One advantage of this system is that if the light output goes down because of the lumen depreciation of the lamp, then this system can compensate for it because it can increase the light output till the desired lux levels are achieved. Usually these sensors would have a narrow field of view and they should see only the task environment. They should not see the window or the lamps, because the direct light coming from the window or the lamps would give wrong signals to the sensor. Now let us look at open loop daylighting control system. In case of open loop daylight control systems, we put the sensor generally outside the building. This sensor doesn't face the task environment. It faces outside. It can only measure the daylight that is falling onto it. It cannot measure the artificial light. So in this case, based on the daylight that is falling onto the sensor can control both the blinds as well as the artificial light and try to maintain the desired lux levels. However, it cannot take into account the window treatment. If somebody closes the window, the sensor will not come to know and it will assume that the light is going through the window. Usually these sensors would have a wide view angle so that it can capture the overall brightness that is there, and usually these sensors would have a wide view angle. The advantage of closed loop sensor is that if somebody closes the window, then that sensor will be able to detect that, because the lux levels on the table will change when the window is closed. In case of open loop, it will not be able to detect it. So how are we basically achieving the control of the artificial light? We know that the daylight, when it enters from the window, it doesn't enter and reaches all the spaces in the building. More daylight will be found near the window and less when we go deeper into the building. So this is not a uniform distribution. Therefore, the interior lights also should have non-uniform control. It should not happen that all the lights are dimmed equally. Generally, we will have 3 zones in a building. The perimeter zone generally would be dimming more than the core zone, because the perimeter zone will see more daylight coming in. So in this figure you see that the perimeter zone is totally off and the middle zone, which is between the perimeter and the core zone, is 50% off, and the core zone is 100% on. So like this, we are able to compensate the variation in the daylight by putting varying artificial light and trying to achieve uniform illuminance near the targeted levels throughout the space. The daylight control not only can help us achieve the right lux levels throughout the space, but it can also help us in controlling the glare. It can control the shades or other devices whenever there is a possibility of glare. It can also control the heat ingress into the building. When there is too much of heat coming from the window, the shades on the windows can be closed and the heat ingress can be reduced. So what is the impact of daylight controls? We can divide the impact into two aspects, the energy aspect and the indoor environment aspect. From the point of view of energy, we save on the artificial lighting energy. It can be up to 100% in a very nicely daylit building. We save on the cooling associated with the heat that is generated by the artificial light. We can also reduce the peak energy demand during daytime. From the indoor environment point of view, the control can help us in minimizing daylight glare. It can also help us in maintaining thermal comfort. People who sit close to the window can feel uncomfortable when direct solar radiation is coming through the window and warming up the space near them. The daylight control system can also provide views to the exteriors whenever there is an opportunity. These systems can open and provide nice views outside. Overall, all these controls can help in increasing the productivity, can help in improving the general health and circadian rhythm of the occupants. So what are the components of daylighting controls? We can divide them into three. We can say that there are sensors, then there is some control logic, and then there are actuators. Sensors can be as simple as an illuminance sensor, a pyranometer, or can be more complicated like sky scanning unit, sun tracker, or sky camera. Besides measuring the light related parameters, we also measure different other parameters, and one of the most common one is to measure the occupancy in the space. For measuring that, we can use motion sensor. Once we have sensed, naturally we will like to control something. So the actuators that are commonly used in buildings are shades and blinds, awnings, louvers. We can control them according to the requirement, according to the sun angle, according to the light that is coming in through the window. There are also apertures which can be controllable. These can be found in light pipes. So if too much light is coming from the light pipe, the aperture inside can reduce the area and less light will come inside. We have already seen smart glass. So we can control the smart glass and change its transmittivity as per our requirements. And naturally, besides controlling the daylight coming into the space, we can also control, and we should actually control, the artificial lamps, because energy savings will only be achieved when we reduce the indoor daylight illuminance by reducing the light output from the artificial lamp whenever there is enough daylight available. Now the question is, what is the logic which sits here and controls these actuators? So a simple logic would just measure the illuminance level on this task environment. The signal can come from an illuminance sensor or any other sensor, and then try to maintain it by controlling the daylighting devices as well as the artificial light. However, usually it is not that simple. We might like to control glare. So estimating glare is not that easy. We might also like to control based on other parameters like outdoor temperature. Just imagine a case if it is a building in a cold environment and say outdoor temperature is -5 degrees and it is night time. Usually we will think that as there is no sunlight, why would I need to control the daylight devices. But in this case, in the night time when the outdoor temperature is so low, the building would be losing heat, and we might like to control the shade and bring down the shade, not to prevent any light from coming inside to outside or from outside to inside, but for increasing the insulation on the window so that the heat that is going out from the building is reduced. So the daylight control systems can also operate on temperature. We can even imagine the other way around. In case of summers in a tropical region, when we are doing cooling inside, if the outdoor temperatures are high and a lot of light is heat is coming as well as light is coming through the window, and if the space is unoccupied, we will not like to provide the desired lux levels, because if the space is unoccupied, we are unnecessarily bringing in daylight and heating up the space. So we might like to close the shading devices and reduce the heat ingress from the window. So the control logic can be based on various other factors such as the cooling load, heating load, occupancy, and the solar radiation that is falling onto the window.